In the FE Electrical and Computer Exam specification, they have 3 topics listed under signal processing as A, B, and C: sampling, analog filters, and digital filters. Within sampling, they mention aliasing and Nyquist theorem, and within digital filters, they mention Z transforms and differential equations. Now, if you want to take a simplistic approach towards exam preparation, your starting point would be the topics that are outlined in the exam specification, and then you will go to the NCS FE reference handbook, look at the references that they've provided for that particular section, and then go about your exam preparation. In my opinion, this is probably going to get you in the 60-70% range, because without taking a holistic approach, you will potentially miss out on fine details. For example, in signal processing, when they mention aliasing in the exam specification, when you look at the reference handbook, there is no mention of aliasing. Aliasing basically happens when you don't sample the signal at Nyquist rate. There are underlying formulas involved with aliasing, which I discussed in my FE Electrical and Computer Exam Preparation program. Similarly, there is no mention of convolution in the exam specification, but in the reference handbook, there is continuous time convolution as well as digital convolution. Now, anybody who's preparing for signal processing, if you have taken signals and systems in your undergraduate engineering coursework, you know that convolution is an integral component of signal processing. Some students believe that because convolution is not explicitly listed under signal processing in the exam specification, it is not part of the curriculum. Within my FE Electrical and Computer Exam Preparation program, both in on-demand as well as live training, we learn convolution from first principles. It is a difficult topic, and that can be part of the reason why students feel tempted to skip it. Skipping any topic on the FE Electrical and Computer Exam is a very risky proposition, because you never know if they will be asking an easy question from a difficult topic or a difficult question from an easy topic. Feel free to check out the NCEES FE Electrical and Computer Sample Exam. You will see a very broad spectrum of difficulty levels, and difficult questions cannot be simply attributed to a particular section. Another reason why signal processing is a difficult topic for students is that majority of the students who are in my FE Electrical and Computer Exam Preparation program have power systems background, and I'm assuming that is the case for most of the students who are taking FE Electrical and Computer Exam. As power systems engineer, you do not deal with signal processing on a day-to-day basis. In fact, you probably don't deal with signal processing at all. You are more likely to get involved in discussions around voltages, currents, square root 3, 30 degrees, delta, y, and so on. Which means that the last time you dealt with signal processing was whenever you took your undergraduate engineering coursework. About 50% of the students who are enrolled in my FE Electrical and Computer Exam Preparation program have been out of school for more than 5 years. Typically, Signals and Systems is an undergraduate engineering course that is introduced in level 2 in your second year of engineering. So even if you're a recent graduate, chances are that you took Signals and Systems at least 2 years ago. The third reason why signal processing is challenging is because there's a lot of math involved. You probably chose engineering because you were decent with math. So that in itself should not be a problem. But the issue is that we typically don't do Z transforms at work. We typically don't deal with difference equations at work. And that's what you encounter in signal processing. Within my FE Electrical and Computer Exam Preparation course, I help the students understand both the summation formula for Z transform as well as using the transform pairs that are provided in the NCS FE reference handbook, which by the way is your only resource on the exam. You also have to learn partial fraction expansion in order to deal with inverse Z transforms. As far as analog filters are concerned, transfer functions come into play. I tell my students that the only way to really truly understand analog filters is to actually derive the transfer functions for low pass filters, high pass filters, band pass filters, and band reject filters. Each one of these filters have multiple implementations. So until and unless you go through the process of step by step deriving the equations, you won't really get to appreciate them properly. And even with the circuits and the formulas given in the reference handbook, you can be easily tricked on the exam. The combination of all of these reasons makes signal processing a challenging section for most of the students who are preparing for FE Electrical and Computer Exam. I hope you found this video helpful. If you have any questions regarding communications or FE Electrical or P-Power exam preparation in general, feel free to drop them in the comments section and I'll try to respond to them as soon as possible. If you're looking for a streamlined exam preparation resource for FE Electrical and Computer Exam preparation, then please check out my program at studyforfe.com. Thank you.